Back friends, my name is Satyajeet Sahu and we are going to have a very wonderful session today. We'll be solving 50 MCQs for which subject? For open channel flow, right? So open channel flow is very important subject. We can say it's a very small subject, yes, but every examination they ask questions from this open channel flow. So let us welcome all the participants who all have come to attend this particular course. Okay, so welcome Abhishek, yes, and Nikki and other participants who will be joining also, and also who are watching this particular lecture recorded. Okay, now this particular lecture is designed, okay, these MCQs, okay, these 50 MCQs are designed so that it will not only suit your GATE or ESE, it will also suit any public service examination. So it will suit TSPSC, right? If you are appearing for Telangana State Public Service Commission, yes, it will suit any particular, PSU like HPCL or BEL or CIL, yes, or your JKSSB, yes. So what happens? We know that when you're preparing for GATE, automatically your preparation for all the examinations happens. That's true. But another fact is that we have to reorient ourselves by practicing the questions which are asked in these examinations, by discussing questions which are asked in this particular examination. Yes, and therefore I am conducting these sessions, okay, these MCQ sessions. We have already conducted many MCQ sessions like for strength of material, yes, for cement, if you remember, right. Last week we conducted for RCC, yes. So these MCQs I will be conducting every week, I can say every week or every 10 days we will be conducting for one subject, where we will be discussing the questions which can be asked in the state examinations. Also, these questions can be asked in what? GATE 1 mark, yes. This question can be asked in GATE 1 mark. These questions can also be asked in what? In ESE prelims, yes. In ESE prelims also they can ask these questions. And any public service commission or SSC JE, yes. So any examinations you are preparing or any PSU, right? So any examination you are preparing, these sessions will benefit you for any exam. So I will request all the participants who are attending this particular lecture, they keep in mind that whenever I conduct a session like this, top 50 MCQs or top 100 MCQs or top 40 MCQs or top 60 MCQs, that is not only for GATE ESE, that is for what? That is for all the examinations. Okay, so let us start the session without any further delay. Okay, my name is Satyajeet Sahu. I have 10 plus years of experience in GATE and ESE and engineering examinations, okay, domain, yes. So I have done my BTech and MTech from IIT Kharagpur. Many students already know me. If you don't know me, then you can go through these credentials. Okay, I teach all the civil engineering subjects. Okay, so some announcements before going to the class. Okay, so we are going to start Mega Marathon or Maha Marathon series. Okay, from 3rd of January, the schedule will be out soon. Okay, from 3rd of January we are going to start this for the GATE aspirants. So daily one subject, 4 hours or 5 hours or 6 hours depending on the length of the subject, will be completing the revision, quick revision, right? So please subscribe to this channel so that you get the required notification. Okay, and 1st of January, okay, so first day of the next year, 1st of January 2023. So 1st of January, 12:30 p.m. in the afternoon, okay, Dheeraj sir will be taking a session on the strategy to be in the top 1% of the GATE 2024. Not 2023, we are already doing the sessions. So those are starting fresh for 24, or if you have some juniors, you can always refer this. And this will be in the BYJU'S Exam Prep app. BYJU'S Exam Prep app. So download the app. Okay, it will be in the app. See, now some lectures will be in the app, some lectures in the YouTube channel. So I will recommend that you download the app so that you will not miss any important sessions. So let's start the session. Okay, so everybody is ready. Everybody is ready. So we'll be solving how many questions? 50 questions. 50 questions. Okay, and target time will be 50 minutes, at least 1 hour. Okay, we'll try to complete in 1 hour, but I will be discussing the answers and explaining also, so it might take some more time, right? It might take some more time. Okay, so 50 questions, everyone is ready? Okay, so let us start. The first question is this one: the Cheji, the relationship between Cheji coefficient and Manning's equation. We know that we use the Cheji's equation. This is the Cheji's equation. Yes, this is the Cheji's equation we use to find out the velocity. Yes, and also we use the Manning's equations to find out the velocity. Right? We use these two relations to find out velocity in uniform flow. Right? Uniform flow. Right? Where R is the hydraulic radius. What is R? R is hydraulic radius, means what? Area by weighted perimeter. Right? This is what? This is cross section area by what? Weighted perimeter, right? Cross section area by weighted perimeter. Yes. So how you can establish relation? People are telling B. Yes. How can establish relationship? Okay. We equate these two. So I can say 1 by n r to the power 2 by 3 s half becomes equal to what? C r to the power half s half. So what happens? S half get cancelled. So from here you can see when you find out C is equal to, so r to the power 2 by 3 minus half. That makes it 1 by 6 divided by the Manning's coefficient. This is the relationship. So B is the right answer. Okay. Area of flow, area of flow, area of flow. Wherever water is there, na, water is there. Okay, area of flow, water is there. What the water is there? Okay, the dimension of Manning's coefficient. Okay, now see, all these questions you can easily solve if you know the formula. So what is the dimension of Manning's roughness coefficient? So from this also you can find out. Chalo, tell me, what is the dimensions of Manning's roughness coefficient? Please tell me. So see, velocity will have dimensions. See what I can say, the Manning's coefficient is r2 by 3 s half and then v. You see, r will have dimension of length, na? So l to the power 3. Slope will not have any dimensions, and velocity will dimension of what? Meter per second. So this is a dimension of your velocity. So this will be how much? L minus 1 by 3 then t. So answer is B. See, all these questions you can solve by easily solve by knowing what the formulas. Next question for Cheji. Okay, somebody answered for Cheji also. Very good. So please mention other people. What is the answer for Cheji? What is the answer for Cheji? B. Here for Cheji. Same equation for Cheji. Cheji constant. So B is equal to C R half S half. So I can say C will be equal to V by R half and then S half. B is what? B I can say is L t to the power minus 1. And this is L half. Slope doesn't have a unit. That is L half t to the power minus 1. Answer is C. 3 questions are over. Okay, now this. Okay, the relationship between Manning's coefficient N and the friction factor F. What is the right relationship? Any idea? I'll give you a hint. Cheji's constant is root under, I'll give a hint, Cheji's constant is root under 8g upon F. This is the relationship between what? This is the relationship between your Cheji constant and F. Now can you establish relationship between N and F? If I know this, D or any other option. See, what was the C is equal to how much we got? We got R 1 by 6 divided by N. Now just relate and tell me. In place of C I can write down this, na? 8g by F is equal to R half R 1 by 6 and N. If I take a square, what will happen? 8g by F is equal to R 1 by 3, na? means square means 1 by 6 into 2. So 1 by 3 by n square. So what I get? I get this relationship. You see, n square is equal to f r to the power 1 by 3 by 8g. Okay. So if you cannot remember this, then just remember this, na? This is easier to remember. Even they ask this also, right? Cheji also they ask. Okay. And this too you can derive, I told just now. So by equating these two, you can find out this relationship also. Yes. So 4 questions are over. 5th question. What are alternate depths? What are alternate depth? Tell me. Alternate depth in open channel flow. Ladies and gentlemen, these sessions are designed for all the examinations. Okay. So they are not only for GATE, they GATE 1 mark and other state exams and ESE also. What is the answer to this? Alternate depth in open channel flow are depth having what? Same specific energy for a given discharge. Next question, question number 6. Which of the following conditions is the chief characteristic of your critical flow? So at critical flow, which of the following relationship is valid? Which of the following relationship is valid? See, Q is discharge. Q is discharge. Okay. T is the top width. T is what? T is the top width. A is the area of cross section and G is G. Yes. Cross section area means, see, cross section area means this one, you see. Cross section area means this one, means how much water is there. That is the cross section area. Okay. Yes. So answer is A. Your Q square T by A cube G is equal to 1. And this is valid for which cross sections? This is valid for all cross sections. For all cross sections, let that be rectangular, let that be triangular, let that be trapezoidal, let that be circular. For every cross sections, this is valid. No, not in mechanical. They ask less. They ask less. Some exams they ask, but civil it is prominent. Civil it is prominent. They ask less. Mechanical they can ask, but ask less. 7th question. Okay. For determine the critical depth applicable to channels of any shape, the length parameter used with average velocity is. Yes. See, for finding critical depth, okay, for finding critical depth, okay, we use this, na? This relation we saw, right, is equal to 1. We also use Froude number. What is Froude number? V by root under GD, right? Remember? And this is what? This is your average velocity. This is average velocity. Yes, we say na this Froude number is equal to 1, and actually this is Froude number square actually, right? And this is the hydraulic depth we use, the length parameter, right? Hydraulic depth. So what is this hydraulic depth? What is this hydraulic depth? Tell me. What is this hydraulic depth which we use with Froude number? That is what? Ratio of area to top width. This hydraulic depth is what? Ratio of area by top width. Actually, if you see this equation, I can write down this as what? You see, Q square by A square, A by T into G. So what happens? Q square by A square will become V square, na? Yes, V square. And this A by T will become what? D. And this becomes equal to 1, and this is nothing but what? This is Froude number square. Okay, this is what? Froude number square, right? You see, Froude number square. Understood? Next question. Question number 8. Okay, answer this question. Okay, for a triangular channel having two horizontal is to one vertical. One vertical is to two horizontal slope. Okay. Okay, the Froude number is given by which equation? The Froude number is given by which equation? Tell me. The Froude number is given by which equation? Okay, very easy. Actually, this is V by GD. That is the Froude general equation for any cross section. Now, suppose whatever might be this, see, here it is 1:2. It can be 1:m, na? It can be 1:m. Any slope they give. So if this is y, depth of flow, this will be my. This will be my. 1:m. So y is to my. So this is my means this is also my. So what will be the area of this? The area of this will be half base into height. That is how much? I can say my square. And what is the top width? The top width is 2my. So I can say the hydraulic depth will be always how much for a triangular section? It will be always my square divided by 2my. That is how much? Y by 2. It will always be y by 2, whatever is the slope, doesn't matter, right? See, whatever is the slope doesn't matter. It will always be y by 2. So what happens to the fruit number? It is v by root gy by 2. Understood? Very good. 8 questions over. 9th question. Is a question, if the critical depth for a rectangular channel, the critical depth is 2. What is the specific energy at critical depth? Means what? The critical energy. What is the critical energy if the critical depth is given for a rectangular channel? What is the answer to this? Very straightforward question. So remember that the critical energy is how much? 1.5 times of your critical depth. Now this is valid for what? This is only valid for rectangular section. It is only valid for rectangular section. How? You see, what is specific energy? Specific energy is depth of flow plus v square by what? Your 2g, right? V square by 2g. Yes. Now critical will be all critical velocity and critical depth. Okay, critical velocity, critical depth, right? Now see what happens for a rectangular channel. For a rectangular channel, what happens? You see, fruit number is 1 at critical depth. At critical depth, fruit number is 1. Okay, fruit number is 1. Now what is fruit number? V by root GD. Yes, and obviously this will be what? VC, because it is critical, right? Critical. Now what happens here? Now what happens here is that when I am saying that your D is what? A by T. So for a rectangular channel, area is what? Width into the depth of flow, right? This is the area. And what is the top width? Top width is B only. So for a rectangular channel, D is equal to Y only. So what happens? This becomes Y, or I can say YC. So yeah, I can say from here that VC is equal to root GYC, or I can say VC square will be equal to what? GYC. So here I can put what? GYC. So what happens? GG get cancelled. I get what? 1.5 YC. Yes. So from here I can say 2 into 1.5, that is what? 3 meter. Question number 10. Okay, answer this question. In a rectangular channel, the depth of flow is given 1.6. The specific energy at the section is given this. Okay. The flow is what? What is the flow? What is the flow? And this is critical specific energy. Sorry, it is critical specific energy. Word is missing. It is critical specific energy is 2.7. Now tell me the flow is what? Depth of flow means it is depth of flow 1.6 meter. Now from the critical specific energy I can find out what? I can find the critical depth, right? I can find the critical depth. Critical depth, how much you are getting? 2.7 by 1.5. Yes, I can say if I divide by 3 or divide by 3, so it will become 0.5 and this will become 0.9. 9 by how much is this? 9 by 5. How much 9 by 5? 1.8, na? Yes. Critical depth is 1.8 meter, right? Critical depth is 1.8 meter. So what happened? The depth of flow is less than the critical depth. This is which one? When it is less. When it is less, now flow is possible. Why flow is not possible? Flow is possible. This is supercritical. This is what? Supercritical. This is what? Supercritical. You see, I will draw here the curve. This is the curve, right? Something like this. Yes. You see, this is critical depth. This is critical depth. When the depth is more, it is subcritical. Remember this, students get confused. Depth is more, it is subcritical. Depth is less, it is supercritical. Depth is less, it is supercritical. Understood? In subcritical, what happens? The Froude number is greater than 1, sorry, less than 1. Okay. So we say this sub or super with respect to what? This 1. With respect to what? 1. We don't tell in respect to depth. This you understand. Many students get confused. They think that, subcritical means sub. Sub means less than. No. Understood? That is the misconception, or we can say mistake we might do. Sub is with respect to what? Froude number. So subcritical I can say here that subcritical means what? Froude number is less than 1. The depth is just opposite. Means what? Y is greater than what? YC. Okay. And when I say supercritical, that means what? I am talking about the Froude number being greater than 1. So this super sub is respect to Froude number. Remember this. And Y is what? It is less than YC. Just the opposite, right? Okay. So I can say it is supercritical. Answer is your B. Next question. Okay. Answer this. At depth of 0.6 meter, Froude number is 2. What is the specific energy for a rectangular channel? Froude number for a rectangular channel is V by GD. This is given 2. See, for rectangle I can also write as V by GY. Okay. Find out. Y is given. Specific energy will be what? E is equal to simply Y plus B square by 2G. See, all these questions you can solve without calculator. Yes, all these questions can be solved without calculator. D, very good. D, very good. Yes, you see from here I can say that V will be equal to, V square will be equal to, I can say 4GY, right? 4GY I can write down from here. Yes, from this thing. And here I can put Y is equal to 0.6 plus. When I put here 4GY divided by this is what? 2G, na? 2G. So 2G, this gets 2. So 2 into Y is 1.2. 1.2 plus 0.6 is 1.8. It's very simple things. Okay, they ask in the examination. Question number 12. Okay. The Froude number is given 2.83. The ratio of critical depth to normal depth. Okay. So this question is very commonly asked. I will give you the formula. The formula is YC by YN. YC by YN whole cube is equal to F square. Okay, this is the relationship. Okay, YC by YN whole cube is equal to F square. So if you know this relationship, you can easily solve this kind of questions. So remember this and answer me the answer question. Remember this relationship. YC by YN, or I can say simply YC by Y cube also. This ratio is equal to Froude number square. How much are getting, other students? Hare, you are not able to do this one. Huh? Froude number is given 2.83. 2.83 square is 8. So they can say YC by YN whole cube is equal to what? 2.83. See, 2.3. You can do approximation. Na? 3 square is 9. So 2.83 will be what? 8 only, na? Do some common sense, na? And YC by Y1 will become what? Equal to, this is 2 cube, na? 8, or I can say 2 cube. What is what? 2. Okay. Straightforward question, okay? Straightforward question, and you should be solving these questions, okay? Question number 13, okay. The specific energy at critical depth, okay? And the critical depth is 2.8. And it's a triangular channel with some slight slopes. Okay, answer this question, very straightforward question. Answer is what? A, B, C, D, E, F, G, H, I, J, K, L. It is what? It is A, 3.5. See, specific energy at critical depth for a triangular channel is what? It is 1.25 YC, and it is independent of side slopes. How? You see, what is this? EC is equal to YC plus VC square by 2G, right? Yes. And we know that fluid number is 1, so I can say VC by this is equal to 1, and in triangular channel I can write down is what? YC by 2. Now see, this depth is, hydraulic depth is YC by 2 for any slope, na? Because this was A by T. If you remember, A was what? My square, and this was 2my, so m was getting cancelled, right? So doesn't matter, whatever is m doesn't matter, okay? Whatever is the side slope doesn't matter here. So here, if we put this here, you see this will be YC plus, I can say BC square will be GYC by 2, and then we already have a 2G, so GG get cancelled, I get how much? YC by 4 plus Y, so that is what? 1.25 YC. Yes. So simply 1.25 into what? Into your 2.8 gives me what? Your 3.5. Next question, question number 14. Very straightforward question. For a given discharge in a channel in a critical depth, what is the answer? Question number 14, what is the answer? Just E versus Y plot. Patapat, we're going slow, man. Okay. D, yes, specific energy is minimum here. You see, here, this is the minimum specific energy or the critical specific energy. Yes, or the critical depth. The critical depth, it is minimum. Yes, so answer is D. Question number 15, very straightforward. Just we solved, right? Just we saw the specific energy in a critical flow for a triangular channel. Just we saw, right? Answer is 1.25 YC. Okay, that is the answer. Next question, 16th question. Now this you answer. For a given discharge in a channel, the critical depth is a function of what? For a given discharge in a channel, the critical depth is a function of what? Question number 16. Now this is easy question only, but you know, what is the answer? See, how we find out critical depth? We find out Q squared T by A cube G is equal to 1, right? Yes. So you see, for a given discharge, if discharge is constant, G will always be constant. So everything is depending on what? Area and T, that is what? Cross-sectional things, geometry, so geometry of the channel. Question number 17, okay. For a given discharge in a frictionless channel, two depths which have same specific force are known as what? Same specific force are known as what? Same specific force are known as what? There are two things, right? Same specific energy, right? Same specific force. What is the answer to this question? Sequent depth. They are known as sequent or conjugate depth, which we find in hydraulic jump. Sequent or conjugate depth, remember, and this is alternate depth. This is alternate depth, okay, remember this. So answer is B. Answer is B, okay. Next, question number 18. Rectangular channel 3 meter wide is laid on a slope of this. The average boundary stress for a depth of flow of 1.5 meter. Now what is the boundary stress equation? The boundary stress is, average boundary stress is gamma, in this case water, then hydraulic radius into slope. This is the formula. Now what is hydraulic radius? It is area by weighted perimeter. So if we have a triangular section like this, yes, with depth how much? Your B and this is Y, so depth is Y and width is V, then area will be how much? B into Y, and the weighted perimeter is which one? Weighted perimeter is the part of the channel which is in contact with water. The other one is open to the atmosphere, right? So this is the weighted perimeter. So I can say this is how much? I can say B plus 2y. So put these values and solve. Okay. The answer is in Newton per. Reverse. Okay. I just wrote it wrongly here. I just wrote it wrongly. Specific force, and here it is energy. I wrote it reverse. Okay. I told the correct thing, but I wrote reverse. Okay. Now answer this. Shear stress is what? Tell me. What is this? See, here you will use 9.81 kilonewton per meter cube, right? See, the answer is asked in Newton per meter square. So what you will do? You will convert that into 9810 Newton per meter cube, right? And then you have to find out R, which will be in meter, and S will not have a slope. So what will happen? The answer will come in, S will not have a unit, sorry, not a slope, it should not have a unit. So this is R we have to get. What is the R you are getting? What is the R you are getting? R will be getting as 4.5 by 6, na? I think 3 by 4, na? 3 by 4. R is 3 by 4. And slope is 0.0002. Okay. You have to do some calculations here. This I can see, the things are very far. Okay. So I can take this as 10,000. For ease of calculation, I can take 10,000. So if I take 10,000, this becomes, no, how much it becomes? 4 zeros. I'm getting 0.15. Something is there fishy. How much are getting? R is equal to 0.75, na? So 0.75 into 0.2. How much are getting? 0.15, na? Getting 0.15, na? Getting 0.15 answer? Everyone? Use the calculator, otherwise you can use the calculator, or without calculator also you can solve, right? Yes. This is slope. I think one more zero should come, na? I think slope, one more zero should be there. No, it's correct only. Getting 0.15? Okay. Next is question number 19. Okay, the changes constant is given. Very straightforward question. 2 meter wide, B is there. Bed slope is there. Okay. Find out discharge in the channel at a depth of 1 meter. So with the relation, B is equal to how much? 1 by N, not 1 by N, kg, na? C R to the power half and S half. Let's solve this question. Now see, there is very less chance that they will ask this, okay, because square roots are involved, but this question they can ask in a beautiful manner. Means how they will put the square root in such a way that you can easily find out the square root also. So what is the answer getting? R is how much, by the way? R will be 2 into 1 divided by 2 plus 2, 4. R is 0.5, na? So I can say this as half to the power square root, and then slope is 1 by 800 half. So how much you getting? You see, you can multiply this now. You can take this common. It becomes 1600 and then square root. Now it is easy to find out the square root. So V is how much? V will be getting 60 by 40. That is how much? 1.5. But this is what? This is just the velocity. This is just the velocity. What is arc? Discharge is arc. Discharge will be what? Area into velocity. That is how much? 1.5 into your 2 into 1. That is how much? 3 meter cube per second. So they can certainly ask you questions from Manning's constant, Manning's equation and Chase's equation, but they will give the calculation such a way that you can solve without calculator also, like this. Question number 20. Okay, come on, fast. This question you should solve very fast now. This question solve very fast now. For hydraulic efficient rectangular channel of bed 4 meter, the depth of flow is how much? The depth of flow is how much? Hydraulic efficient sections, rectangular channel. Come on, fast. What is the answer to this? D. Yes. The relation is what? B is equal to 2 into Y, right? So what will be y? Y will be b by 2, that is how much? Your 2 meter. This question should solve very fast. Question number 21, straightforward. For a hydraulic efficient triangular channel, the hydraulic radius r is how much? What is the hydraulic radius for a hydraulic efficient triangular channel? For a hydraulic efficient triangular channel, what happens? The side slope is 1:1. This you should remember, na? It is 1:1. So this is y. This also is y. This also is y. Yes. So this becomes y. This becomes root 2y, and this becomes what? Root 2y. And what is your hydraulic radius? It is what? Hydraulic area by weighted perimeter. Area will be what? Half base into height. So half y into 2y square. 2y means what? Y square actually. And then weighted perimeter is this one, na? Weighted perimeter is this one, this and this. So I can say how much? 2 root 2y. So I get what? Y by 2 root 2. So answer is what? B. 21. Very good. Next question. Question number 22. Answer this. In an hydraulic most efficient trapezoidal channel, most efficient trapezoidal channel, what is the relation of hydraulic radius? I'm not deriving it, I'll write the answer. For trapezoidal, for rectangular and trapezoidal, remember, for rectangular and trapezoidal, remember what? R is y by 2 for most efficient sections. For most efficient sections, R is equal to y by 2, right? And for triangular section, for triangular only, this will be how much? R is equal to y by 2 root 2. Yes, so answer is A here. 23. Answer this question, very easy question. For a most efficient trapezoidal channel, the ratio of bed width to depth. For a most efficient trapezoidal channel, remember this is 2y by root 3, the width. Even side slopes are also what? Same. 2y by root 3, this is also 2y by root 3. This you should remember. Certain things to remember. So answer is what? This 1.115. B by y. You see, b by y will be how much? B by y will be 2 by root 3. So 2 by root 3 will be how much? 1.155. Yes. Now same thing if I ask for a rectangular channel. Same thing if I ask for a rectangular channel. What is b by y? B by y will be 2, na? For rectangular channel, b by y is 2, na? Yes, base width by the depth is what? 2, na? Yes. And for this is the answer. Remember, or they can ask 2 by root 3 also. Next question, question number 24. Okay. Okay, so in a hydraulic jump, when the initial fluid number means F1 is lies between 2.5 and 4.5, then this is which kind of jump? Classified under which kind of jump? Yes, classified under which kind of jump? This you have to remember table. Remember table. I'll tell the table, don't worry. It is classified under which kind of jump? Answer is, when you're telling D. D. D, it oscillating. How to remember? Remember certain numbers. Remember 1.7, 2.5, 4.5, okay, 9. Remember these numbers. Remember these numbers. Okay, remember these numbers. Okay, so if it is, you see, if you remember these numbers, I can say another one. You remember 1. Obviously, the initial fluid number has to be greater than 1. Why? Because here when the hydraulic jump happens, right? So what happens? Here it is supercritical, right? Supercritical means what? It has to be greater than, the F1 has to be greater than 1, right? So things will start from 1 only. Yes. So 1 to 1.7, because this is 1.7, so obviously this will be 1.7, right? This is known as what? This is known as undular, right? Now this is 1.7, so obviously this will be 2.5, because this is 2.5, this will be 2.5, right? And this is what? Weak. When it's 2.5 to 4.5, it is oscillating, right? When it is 4.5 to 9, obviously is 9, right? This is what? Steady. And more than 9 will be what? Obviously it is strong. So see, we normally remember table in this manner. I remember in this manner. If you remember this much, you remember everything, na? Yes or no? If you remember this much, actually even 1 is not required, right? 1 is not required. We can say this is 1.7, so less than 1.7 I can say. It has to be greater than 1, common sense. Yes? So 1.7 to 2.5, 2.5 to 4.5, 4.5 to 9, and then greater than 9. Understood this? Next question, 25. Okay, very straightforward question. Hydraulic jump, the energy loss we have to find out, right? Very straightforward question. Yes, formula is what? Y2 minus Y1 whole cube divided by what? 4 Y1 Y2. Very straightforward question. So answer this. Very straightforward question. So 1.25 into 0.25, right? Whole cube means 1 cube basically, divided by 4 into 0.25, so it's 1, and this is 1.25. So easy calculations, right? It's nothing but 1 by 1.25, and 1.25 is what? 5 by 4. So I can say it is just nothing but 4 by 5, that is what? 0.8. So answer is A. Question number 26. 25th is over, 26th. Okay, channel classification. Okay, channel classification, slope classification. Minus sign. Which minus sign? Doesn't matter. इतना ईट से ईट नहीं मिलाना यार, आंसर निकालना. Okay, so now channel slope classification. Okay, okay, judge this. Normal depth is given, critical depth is given. So tell me, this is which channel? This is which channel? Tell me. 26th question. This is which channel? Normal depth is less. Normal depth is less than YC. Means your critical depth line is above your normal depth line. This is which one? This is steep. Very good. This is steep. This is steep. Yes. When the normal depth is more than the critical depth, means what? Your NDL is above CDL. NDL means normal depth line is above CDL, that is mild, right? And both are equal, then it is critical. Understood? The answer is what? A. Very straightforward question. Straightforward question. Next question. Okay, M1 is which profile? Okay. Y naught is the normal depth. Y naught is the normal depth. Okay. Y is the depth of flow. Y is the depth of flow. Okay. Y is the depth of flow, right? And YC is your critical depth. YC is your critical depth. Now tell me that we are talking about which one? Tell me what is the answer to this? Very easy. Mild slope, remember, mild slope NDL is above, na? NDL is above, and then CDL, na? Mild slope, then CDL, right? And then the bed, right? Yes. You see, this is YN, this is YC. So M1 is here. M1 is here. M1 means what? You see the depth of flow will be what? Greater than both of them, right? YN greater than YC. Okay, so Y is greater than YN. Here YN sometimes they write Y naught also. So this is what? M1. What will be M2 by the way? M2 will be YN. It lies between YN and YC. Na? This is M2. Na? This is M2. Na? M2. So actually this is your M2, right? This is your M2, right? And M3 will be what? M3 will be less than both of them. Less than both of them. So you can say that this is your M3, right? Understood? Very good. Next question. Question number 28. S2 is which one? S2 is which one? Again, but here what happens? CDL is above. This is YC and then YN, na, in steep slope. This is the bed. S2. Tell me what's the right answer? S2. 28. S2. Sometimes they write Y naught, sometimes they write YN. Okay. S2. S2 is here, na? So I can say here it is what? I can say Critical depth, it lies between what? Critical depth and then the normal depth. So answer is what? Your D. Or I can say why not, suppose, if you want to denote in the same notation, why not? Okay. S1 is what? S1 will be Y greater than YC greater than Y naught. Yes. Please study this topic and go to the learn with video lessons. There I have completed GBF. You can refer from there. S3. S3 is what? YC greater than Y naught greater than Y. Yes. Understood? Okay. Let us go to the next thing. The flow will be supercritical in state in which of the profiles? So now the questions are little good. Supercritical state. Supercritical means what? The depth of flow is less than critical depth. That's it. Na? Supercritical means the depth of flow is less than your YC. Now tell me. We draw all the profile, right? M1, M2, M3, S1, S2, S3. But only compare with critical depth. Only compare with critical depth. How S1, S2, S3, Baba? I'll draw everything here, okay? Mild slope I will draw. And critical and the steep also I'll draw. This is steep, this is mild, suppose. So here mild means this is Yn, this is Yc. And this is steep means Yc, this is Yn. Now see this M1. Here it is happening above the critical depth, na? So this is subcritical. M2 happening above the critical depth, na? Subcritical. Now M3 happening below the critical depth. Only see the critical depth. See nothing when you are finding supercritical or subcritical. So this is supercritical, right? Now in case of steep, S1 happening above, so sub. Okay, only see critical, don't see normal now. Here happening below, so super. Happening below, so super. Very good. So what is the answer here? S2, S3 and M3. Understood this? Understood this? See, they can ask you subcritical also na in the examination. They can ask you subcritical also na. Yes, just subcritical and supercritical. Just compare depth. So Y is less than Yc, it is supercritical. Y is greater than Yc, it is subcritical. Easy. Next question, question number 30. Okay, channel transition. So when we have a mild slope and changes to steep slope, so what happens? When we have a mild slope and changes to steep slope, so what happens? Which profile is found? See, whenever there is a change, critical depth doesn't change, because critical depth only depends on the discharge and geometry. So critical depth, sometimes not geometry also. So critical depth is same. What will change? Normal depth will change, na? In case of mild, it will be above the critical depth. In case of your steep, it will be below. Yes or no? So this is steep, this is mild. Okay. Okay. So the critical depth will not change. The normal depth will change. The normal depth will change. So now flow always occurs at normal depth. So here it is occurring at normal depth. But when there is change in the slope, what will happen? There will be transition like this. And here it will try. It will try. What will try? The flow will try to go from normal depth to normal depth. From normal depth to normal depth. So like this it will go like this. Normal depth to normal depth. Normal depth to normal depth. Now tell me what is the answer. Always the flow will go from normal depth to normal depth. Remember, the flow will always go from where? Normal depth to normal depth. Yes, here normal depth. Okay, here normal depth. So it's like, flow always wants to be at normal depth. But there was change in slope, so therefore it has to go from one normal depth to another normal depth. So there was some transition. And you can see that this is mild, this is second zone, na? So this is M2. And this is steep, this is also second zone, na? So S2. So M2, S2. And here at the junction, the depth will be what? Junction, the depth of flow will be equal to the critical depth. Yes or no? At the junction where this is changing, the depth of flow will be equal to the critical depth. Everybody understood this particular diagram? Everybody understood this particular diagram? Clear? Clear? Now tell me, these particular sessions are for which examination? Can anybody say that these sessions are for which examination? You can see that the sessions are designed in such a way that it caters for all the examination, right? That is the expertise, okay, that's the expertise I have over the years. The sessions are so beautifully designed that it will help you in all those examinations, okay? Okay, 30 is over, 31, okay. Which of the profile doesn't exist? Which of the following doesn't exist? See, in mild all the three exist, right? M1, M2 and M3. All the three exist in mild, okay? In mild all exist. In steep also all exist. Steep also all exist. S1, S2, S3. Then critical what happens? In critical, Yn is equal to Yc, na? In critical what happens? In critical what is the problem? Yn is equal to Yc. So there is no second zone. If you see, this second zone was always between this Yn and Yc, na? You see, second zone was always between Yn and Yc. So in critical, the second zone is not there only. So I can say there will be C1 and C2. So C3, C1 and C3, there is no C2. So C2 is what? Missing here. C2 is missing. Okay. Now what happens in case of your horizontal what happens? In horizontal slope, the normal depth is at infinity. So we have only a critical depth and the normal depth is somewhere at infinity. So infinity. So can there be flow above infinity? Can there be flow above infinity? In horizontal slope, what I told, this is critical. This is critical and this is what? Horizontal. In horizontal slope, the normal depth is at infinity. So flow cannot be above Yn. That means what? There is no H1. So there will be only H2 and H3. So I can say in horizontal, there will be H1, H2, H3. H2, H3 will be there, but H1 won't be there. And for similar regions in adverse, the negative slope, there also I can say the A1 is imaginary there. A1 is imaginary there. So what will happen? A1 won't exist. Okay. Understood? So which is the answer now? Which is the answer now? Tell me. Which is the answer now? Your A, na? A is the answer. Now tell me how many profiles are there then? How many GBF profiles are there? How many gradually varied flow profiles are there? Tell me. Total. Count them and tell. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 are there, right? Now C1, can I say C1? C1 and C3 exist. Okay, yes. Total how much? I told total is 12. That is the next question actually. That is the next question. So how many total number of possible GBF profiles? 12. Question number 33. Okay. Read the question and solve the question. Little tricky but easy. I have combined critical flow condition and minimum perimeter. Minimum perimeter means what? Minimum perimeter is, it is hydraulic efficient section, right? It is the efficient section. Minimum perimeter is the efficient section, okay, indirectly. So do whatever you want but solve this question. Chalo, I'll give you some time. You're going fine. You have covered so many things in less than 1 hour, right? More 17 to go. Please solve. Fast. 1.8, yes. Efficient section means what? B is equal to 2y, yes. So B is given, that means y is given, and this is critical flow also. It is critical flow also, it is efficient also. So B is equal to 2yc, I can say yc is equal to how much? 1.2 meter. So what will be critical specific energy? That is how much? 1.5 times of yc. So two conditions, two formulas combined and we get another question. Very simple question, but you see, if you don't know the conclusion, then you will not be able to solve this. Next question, 34 question. Something on the hydraulic jump. Okay. So the Froude number of the supercritical stream means what? F1 is given. Okay. The sequent depth ratio. Sequent depth ratio is what? Y2 by Y1. And this Y2 by Y1 is what? Half minus 1 plus root under 1 plus 8 F1 square. This is the formula. This is the formula. Now you see, options are given. We can roughly find out. You see, Y2 by Y1 will be what? I can say half minus 1 plus root under, I can write down 1 plus 8 F1 square. F1 is 12. So F1 square will be 144. I can do this calculations also. This is 32, 3, 35, 3, 11. Getting 1152. 1152, this is 1153. See, 1153. Now you will tell her I don't know square root. Why you don't know square root? If you don't know, just do a guesswork. See, 30 is what? 30 square is 900. Yes or no? 30 square is 900. 40 square is how much? I can say 1600. So this will be in between something, na? In between something, you can take 35 around. You can take 35, na? 35, 34. Let us take 34, huh? Let us take 34. So what will happen? 34 minus 1 is 33. So 33 divided by 2 is 16.5. Answer is 16.5. Yes, those options are there. It's not a data entry question, right? You don't have to be exact. You see, what is the exact square root of this? Exact square root of this 113. 1152, na? 53. Exact square root is 33.96. Exact square is 33.96. We can take, na, do approximations. See, even if you take 35 also, suppose you take that as 35, okay? Suppose you take that 35 also. Then also what will happen? You will get 17, na? So 17 is close to this, so you can guess that is the right answer. Right answer, na? Understood? So do some guesswork also when the options are given, and don't worry, the options will be widespread. Don't worry. Don't think that they will give 16.45, 16.55, 16.65, 16. If they give like that, then leave the question. Or find out, do Vedic mathematics. Some people tell, I better leave the question, better than I will solve 5 questions than to use Vedic mathematics and West. Okay, understood. This is 16.5. Put this as 12 square. You can solve this question. Next question. 35. Okay. At the point change of grade from mild to steep in a rectangular channel, the depth of the flow is observed as 1.6. This 1.6 is which one? When there is change of slope or change of grade, okay, at the point change, what I told, the depth of flow is YC, na? Point of change, depth of flow is what? YC. So indirectly what is given? YC is given here. YC is given 1.6 meter. The discharge per unit width, small q, is asked. How you will find out this? YC cube is equal to q square by g, na, for a rectangular channel. Remember this formula? Now, it is very difficult that they will ask you q, see, means YC from this formula. Because if they give you q and then YC, it will be difficult because you have to find out cube root. But the reverse they can give, na? Yes, that is easy. YC cube means what? 2.56 means 1.6 square and then 1.6 is equal to q square by g. You can take 10, g you can take 10 approximate, because you find approximate answers. So this becomes 16, right? This becomes 16. So q will become equal to what? 1.6 into, this will be 4. So close to 6.4. Answer is what? 6.35. Understood? Don't use calculator from this MCQ series. Means these questions which I am solving, because this see, if they can see, they tell me this question they can ask in ESE also, na, ESE prelims also, na. Yes or no? This question they can ask in ESE prelims also. So what you will do? Open calculator. So don't use calculator now. In GATE sessions you open calculator. But for these sessions, when I tell don't use, mean don't use. Don't use. You can find out by common sense also. Okay. So, okay, very good. Next question, 36th question. It's a very common question asked in many exams in ESE. This is a ESE question actually. So what is given? Rectangular channel carries a discharge of 15 cubic when the bed slope is this. What is the discharge when the bed slope is changing to this? See, we know that discharge is what? Area into velocity. Now, if the area is constant, the slope, the velocity will change if there is change in slope, because the velocity depends on slope. Let that be Chg, let that be Mannings, right? So I can say Q1 by Q2 will be equal to, the area is same, only this changing, so velocity will change, V1 by V2. You see, whatever equation you take Chg or take Mannings, if only bed slope is changing, that means it will depend on the bed slope change, right? Okay, and in both equation it is what? Slope to the power half. In both it is what? Slope to the power half. So first it was 15, second I don't know x suppose. First slope was 1 is to 14, 1440. Second one is 1 is to 1000. There's square root of this, so this get cancelled. I get what? This I get as 10 by 12, right? So I can say x is equal to 12 into 15 by 10, that is how much? I am getting 18. Understood? Easy question. And they can ask this question in your examination, right? Even this question was asked in prelims examination. In ESE prelims they asked this question. Okay? In ESE prelims they also asked this question. You might have taken the reverse. 21.6 you might have taken the reverse. Means what? You have done this. Something you have done. Some great thing. What great thing you have done? What great thing you have? Somebody is dating D. How? Or I did some great thing, huh? No. Root नहीं किया, ओ हाँ root करना है ना. Slope, it depends on slope ना. Velocity is what? Whatever equation you see Chg or you see Mannings. Okay. उल्टा कर दिया, हाँ. Big, see, slope means 1 by this. Okay. You see Chg or you see what? You see Chg or you see Mannings. In both, if cross section is same, then what? R will be same. So only bed slope is changing, means it will depend on square root of S only. Understood this question? Understood this question? Very commonly asked question. Question number 37. Okay, very straightforward. Now all memory based. For most economical sections, tell me, for most economical sections of triangular section, the angle of sloping side with your vertical, what is the answer to this? What is the answer to this? Remember, for most efficient triangular section, what happens? What happens? This is 1 is to 1. If this is 1 is to 1, that means what? This is 45 degree, na? Theta is 45 degree. They have asked with vertical, so this is 45, means this is also 45, right? With vertical also it is 45. So answer is 45 degree. Understood? Next, for most economical trapezoidal section, the slope, angle of sloping slide with vertical is what? Tell me. For most efficient trapezoidal section, what is the answer? फंस गया. That is with horizontal. That is with horizontal. It is asked what? Vertical. 30 degree. Understood? Understood? See, for triangular, it is 45 both sides, because doesn't matter. 45 both sides doesn't matter because 45, right? But here it matters. With horizontal, it is 60 degree. Okay, with vertical, it is 30 degree. Remember this. Next question, 38 question. The depth of flow in a circular channel of diameter 2 meter for maximum velocity condition. Answer. Remember that for maximum velocity condition, right, your y is equal to 0.81 t, right? And for maximum maximum discharge condition y is equal to 0.95 d. This is h per what? This is h per kg. Okay, and h per Mannings it is 0.938, right? And this remains same for both conditions. Okay, so now it is given nothing, both means nothing, Manning charge is not given. So 0.81 into d2, so 1.62 meter. Understood this thing? If the question was for maximum discharge, then this is for maximum discharge. I would have got this one for maximum discharge, right? For maximum discharge, this would have been the answer, 0.95 into 2, right? Sorry, oh, sorry, no, but the 0.95 into 2, 1.9 meter. Yes, but this is asked for maximum velocity. 40 question. Okay, for a most efficient trapezoidal section, the side slope are of length how much? 1.2 meter. What is the top width? What is the top width? For a efficient trapezoidal section, the side slopes are of length 1.2 meter. What is the top width? Come on, fast. What is the top width? See, yes, remember, if this is the side length, okay, this is the side length, the top width is twice of that for a most efficient. Yes, so it will be 2.4. And base width is also equal to side. This is 1.2 meter. So see, this is 1.2, this is 1.2, this is 1.2. Yes. And we know the formula also. This is 2y by root 3. This is also 2y by root 3. And this is also 2y by root 3, right? Yes. And this will be what? This will be 4y by root 3, right? Twice of that. And this is 60 degree, na? This is 60 degree, na? Yes. Yes. All these conclusions are important. So answer is just twice 2.4. Question number 41. Which of the following flows is not possible? Which of the following flows is not possible? Which of the following flows is not possible? Answer this. Which of the following flows is not possible? Good morning. Which of the following flows is not possible? Which of the following flows is not possible? See, yes, unsteady, uniform. See, steady is with at a certain location. Steady means what? Certain location, and this is variation with time, right? And uniform is with what? With space or length, I can say, right? So steady uniform can happen. That means no, depth is constant with time also at a particular depth, and over a length also you are finding what? Uniform. Steady non-uniform can also happen. You see, this I can say, suppose this is the length of the channel, lengthwise. You can see this is what? Steady also, uniform also. So here depth is same as here depth, and this depth is not changing, steady uniform. There can be steady non-uniform also. Means what? You see this depth. Suppose any gradually varied profile also. What happens here? So what happens, you see, it is not uniform, na? See, depth is changing, but at a particular location with time, that depth is constant. This depth is constant. Yes, if you see at this location with time it is constant, just with length it is changing. So steady non-uniform possible, right? Unsteady non-uniform is also possible, right? Means both it is changing with time also, space also. But unsteady uniform is not possible. Means what? It uniform means it is with space. Okay. So it is unsteady means what? At a certain location it is fluctuating. Yes. If it is not constant at a certain location with time, what it will be constant over the length? Yes. So this is not possible. So this flow is not possible. That is the right answer. Next question. Question number 42. Hydraulic jump flows changes from what to what? Come on, very straightforward question. In a hydraulic jump, right? So flow changes from what to what? Flow changes from supercritical to subcritical. So I can say F1 will be greater than 1 pre-jump. F2 will be what? F2 will be less than 1, right? Pre-jump, right? Post-jump. And your Y1 will be what? Y1 will be less than critical depth because supercritical, okay? And your Y2 will be greater than YC, that is what? Your subcritical, okay? Please take a class on kernel transition. How many classes I will take? Huh? It is there in the app. Have you downloaded the app, Mr. Divyansu? You always come and tell, take this, take that. Have you downloaded the app? I have told many times that it is available in the app. Huh? Have you downloaded the app? Have you seen? Learn with video lessons. I have taken there. So I have taken there, na? I have taken there, na, Baba? I have taught that channel transition. I have taught complete channel transition with see, channel transition question I am not discussing here. Why? Because those questions are more numerical in nature and they cannot be asked in, chances are less in state exam. Yes. So that is more chances in this exam. Therefore, topic is limited. Take the subscription, na. Topic is limited. From last 6 months you are coming and saying topic is limited, topic is limited. And in all sessions we are telling that there is scholarship test is happening. Have you given scholarship test till now? Have you given the scholarship test till now? Have you given the scholarship test till now? Given? Registered for the scholarship test? Every session, no, why you have not registered for the scholarship test? Every teacher is coming and they are informing you about the scholarship test. Okay, there is a scholarship test happening every 2 weeks, every 3 weeks there is scholarship test happening. So if you are studying from the YouTube sessions, okay, and then you are appearing for the scholarship test, you will get a good amount of discount. Yes, 90% scholarship is there, 90%, 75%. So see now what the teachers are telling in the class. Scholarship tests are happening, you are not registered for the scholarship test. Please register for the scholarship test. Okay, so register for the scholarship test. You can give the scholarship test, then you can access all the videos. Okay, chalo. Supercritical to subcritical. Okay, next. Every class is coming and telling us the topic is limited. Okay, now attend this class. Now attend this class. Okay, your whole attend this class. Okay, when some topic is going on, attend that. Okay, now see. What is the answer to this? Which profile? Tell me. Which profile? Tell me. Identify the profile. See, very good. Others? Okay, I just got a message. So, okay, you see, normal depth is this. What is the depth of flow? The depth of flow is given 75% of this. Means what? 1.2 meter, right? So I can say normal depth is greater than the critical depth. It is greater than what? The Y. So first of all, normal depth is greater than critical depth, means is M, and this is M3. Correct? Next question. Okay, read the question. I will just slide down. Okay. Read this question. Big question. Answer this. Okay, D. Okay. This thing I have discussed before, na? Subcritical means Froude number is less than 1 and depth is greater than YC. Supercritical means Froude number is greater than 1 and Y is greater than YC. Yes. So first one is depth is less, so wrong. Second one, depth is more, so wrong. Subcritical, depth is less, wrong. Depth is not less, na, wrong. Supercritical, Froude number is more than what? Depth is less. Yes, answer is D. Now we'll not get confused in this, right? Now we'll not get confused in this type of questions. Question number 45. For an efficient trapezoid channel, the depth of flow is 1 meter. Area of the section is how much? For an efficient trapezoidal channel, yes, the depth of flow is 1 meter. Okay. What is the area of cross section or area of flow? Basically this is given 1 meter, means Y is 1. I just told the conclusions for trapezoidal channel, right? I just told the conclusions for trapezoidal channel. See, See, this is 4y by root 3, na? And this is 2y by root 3, na? Yes. So we know what is area. Area of a trapezoid is half of the parallel sides. That is what I can say 6y by root 3 here. Yes. Sum of parallel sides into the height. Yes. So this will be equal to, I can say, remember this. The answer is root 3y square. Always it is what? Root 3y square. The area of an efficient trapezoidal channel is root 3 into y square. So y is 1, answer is 1.732. Yes. So if you have attended these sessions and remember the conclusions, you can easily. Now many people will think, Arey Baba, it's a very difficult question, so much research I have to do. Do research, okay? Do research. No research is required for this. Students who are studied from my session, they can easily answer in the examination, right? Those who studied for my classes, they will easily able to answer the questions. Again, all the conclusions you should remember, right? Okay, and those who want to see the derivation of the conclusions, I have derived the conclusions in the Learn with Video Lessons. It's available in the BYJU'S Exam Prep app. Okay, and if you it is showing limited sessions, that means you have to take the subscription. And if you want some scholarship also, scholarship tests are also conducted. So the scholarship, register for the scholarship. Visit the app and don't give the scholarship test and then cry. 46. For an efficient triangular section, the weighted perimeter is dash times the depth of section. Come on, fast. The weighted perimeter is dash times the depth of section. Very simple, straightforward question. Arey, why taking so much of time? Straightforward question, Baba. B, yes. अरे क्या रे बाबा, इतना तुम्हारा टाइम लग रहा है? अरे भैया, √2y, weighted perimeter is what? 2√2y. Yes, 2 into √2, 2.828, 2.83. Understood? Again, I am telling all these conclusions which I am telling are very important in your examination. See, I have covered every part of open channel flow, right? Channel transitions I have not covered because they are more numerical in nature and I have covered them in the app. But for state exams, it is not required that much, therefore I have not taught. Okay. Next. 47. For same critical specific energy, the ratio of critical depth for a rectangular and triangular section. Very tricky question. Many students will get caught in this. Let me see. Am I able to uh, make you solve the wrong way or not. Let us see. The ratio of critical depth for rectangular and triangular channel is how much? हो गया गलत हो गया others अरे why I told it's B. You see, critical specific energy is same for both rectangular and triangular. Critical specific energy is what? 1.5 times of this for rectangular and 1.25 times for your triangular. Now what is asked? This rectangular and triangular, right? Ratio is rectangular by triangular. It is what? 1.25 by 1.5. 0.83. Okay? Understood? You did the reverse. Okay, good question. Question number 48. The specific energy and the velocity of flow for a uniform flow is 1.5 and 2.5. But the depth of flow, very straightforward question. Very straightforward question. Specific energy is given, velocity is given, depth of flow is asked. Very straightforward question. Solve this. So if you attend this kind of sessions in 90 minutes or so, in 1.5 hours, I will be completing one subject. Or if the subject is very big environment, then at least I can cover 4 or 5 important chapters in one full sessions for your state exams and other examinations. Per GATE, we are conducting different sessions. It is what? Yeah. See, this is 1.5 na, this is equal to y plus 2.5 means 6.25. See, you can take, always you can take approximation, you can take this as 10 actually. Always you can do that, right? You can take a 10. So this becomes what? 3.125, or you can say 0.3125. So y will be equal to what? 1.5. You can take 0.3 also, right? So approximately it will be 1.2 only. So it's little less than that. So 1.18. Yes, common sense, na? Common sense always you can do. Okay. 49th question. Hydraulic jump is which type of flow? Hydraulic jump is which type of flow? Hydraulic jump is which kind of flow? Hydraulic jump is which kind of flow? बाबा बोला नहीं यार, ये बाबा नहीं बोलना है, वो बाबा और कोई बोलता है. I will not tell बाबा. हाँ, what is answer? B ना? Yes, it is steady non-uniform. How? You see, this is the hydraulic jump. So I can say here depth is y1 and depth is changing to y2. Yes, here it is y1 and here it is y2. Yes, y1 and y2. Yes, so you can see that along the space or length, the depth is changing. So it is what? Non-uniform. It is non-uniform. Yes, but if you see at a particular location, at this location, the depth will be always y1. Means what? At morning 8 o'clock also it is y1, evening also it is y1. Means what? With time the y1 is constant, with time the y2 is constant. It is just varying with the space. So steady non-uniform flow. Even the gradually varied flow are also what? The gradually varied flow are also what? The gradually varied flow are also your this thing. Understood? Okay. Also steady non-uniform. Next, for an efficient rectangular channel, the hydraulic radius is found to be 0.62. The width of the section. Last question. So everything is covered. Last question of the session. Very nice. In 1 hour 20 minutes actually. 80 minutes we covered 50 minutes with explanations. Right? See, hydraulic radius is what? Y by 2, right? And width is what? 2 times of y, right? So I can say that 2 times of y. And y is itself 2r. So it becomes 4 times of r, right? So 4 into 0.62, that is how much? 2.48. Answer is what? See, 1.24 कैसे बासु कूद गया? Don't jump. See the question what is given. Okay. Width this was not given. Okay. So very nice. So see, what all things we covered. You see, started with uniform flow. Means what? J.G. Mannings. We covered everything which they can ask from J.G. Mannings, right? Then from efficient section also I have covered everything. Lot of questions from efficient section. Rectangular, triangular, trapezoidal, circular. Everything I covered, right? Then we went to critical flow. Critical flow also we saw for rectangular, triangular, right? Critical flow, general things of critical flow, theoretical aspects of critical flow, subcritical, supercritical, everything we covered, right? Then we went into GBF. All the profiles also we went. M1, M2, M3, S1, S2, S3, C1, C3, H2, H3, A2, A3. Yes. And then hydraulic jump also, whatever was required, we covered that. Yes. Many things like channel transitions and there are some things like direct step computations and all are there, which we didn't cover because that are numerical in nature and that cannot be covered. That is not required for your state examinations, and also they will not be asked in even ESE prelims also, because see, channel transition you require complicated equations. See, those are very easy actually, but thing is that you need a calculator. With a calculator you can't solve, right, those equations. Lot of cube root and all those things comes. And also there are a lot of questions which are there for hydraulic jump also involving these equations, right? Now this equation I solved only one simple one. There are more complicated ones also. So if you want to cover the complicated ones questions, so those are available on the app. Download the app. You can go to the learn with video lessons. I have covered a lot of things, but that is for the GATE examination. Yes, and these all are for GATE 1 mark and we can say ESE prelims and other state examination. So today's Avinav sir will be coming up with surveying. I think, what is the time? Let me just check. Formula memory test for surveying. Let me just check the time once. Today's session is at 10:45. 10:45 p.m. Today means what? Today is what? 29th of December. Okay. So they attend this session. Okay. Your formulas for surveying will be covered. Then tomorrow at 6 p.m. we will be solving numericals. Okay. From construction planning management. Okay. And numericals from what? CPM and PERT I will solve. And some from building material also. CPM and PERT and building material numericals I will solve. And CPM PERT I will be solving many things like network diagrams and then probabilities and then slack, float, many things I will cover. Okay. So tomorrow we will have this session 6 p.m. 30 December. Please do attend. And yesterday also I took one session on vector calculus. Those who are appearing for GATE and ESE, please cover that. Okay. Okay then, ladies and gentlemen, thank you very much. Okay. And Divyansu, please give the scholarship test. If you are thinking, I know what you are thinking. That will not work. I will not tell also what you are thinking. What you are thinking, I will not tell. But that will not work. Take a structured approach. Okay. And oh yes, this also I informed before. So 1st of January, 12:30 p.m. we will have session by Dheeraj sir. So please attend that. Okay. Thank you very much. Okay. Now the list of all sessions are available with me. If you want, okay, you send me a message. I will connect you to the team. They will send you the link. Okay. This is my contact number. In the contact number, don't write messages like please cover this, please cover that. Whatever you want to request in the comment section on this particular video or any video of mine or other teachers. Okay, FM की क्लास नहीं है भाई, मैं क्या यहाँ पर हर दिन का क्लास लेने के लिए Okay, this is my phone number. Okay, so what I was telling, yeah, so don't write these messages, cover this, cover that. If you have some specific doubt, you send me. Okay. Or I will just connect you to the team. They will send you the links. Okay. Any other requests you have, you write in the comment section of this my video or any other video. That is fine. Okay. Okay. Thank you very much. Okay. Bye bye.